trig equations. Remember I did blow by those couple of pages. There's 2 pages we have to come back to. We have to come back to, or 3 pages. We have to come back to the double angle, using double angle identities. That they were kind of misplaced, and then using the sum and difference identities. So that's the area I'm on right now. But I'm going to start with just the regular identities, and then we'll do identities, the regular identities to solve trig equations. Then I'll talk about using the double angle and the sum and difference, because that's the order we learned them in, right? And these are the simpler identities. Okay. It says solve each equation over the domain 0 to 2 pi. All right. I have to solve this equation. We use all our regular tricks that we always have. Trig functions on one side of the equation, constants on the other. Correct? So, the problem is, though, I have different trig equations. They're not going to be like terms. As opposed to yesterday, when we did a question like this, similar to this yesterday, if I just go back to the beginning. Remember when we had this one? 5 minus 310, and then a 210 plus 9. These were like terms. We put them on one side of the equation, grouped them together, did the math, and then it was isolated with one trig function in no time. I have mixed up trig functions here. So, when we have mixed up trig functions, we're going to use identities to rewrite the equation using only one of the trig ratios. We did a little bit of this at the very beginning of identities when I said, I gave you an expression, a trig expression. I said, write only in terms of sine, right? Or write only in terms of cos, and you could only use cos or only use sine. So what do you see? Let's group these together. Let's put all our trig functions on one side. So I have 3 cos x minus, or actually, let's not do that yet. Sorry about that. Let's just rewrite in terms of one trig function. Okay? So what trig function do you think we're going to rewrite in terms of? Cos, right? So I've got 3 cos x plus 1. There's nothing to rewrite there. 2 sine of x would become, well, 2 times 1 over cos. Or I could write it as 2 over cos, right? 2 times 1 over cos is the same as 2 over cos. Agreed? Okay. So now I have everything in terms of cos. And I have to solve this equation. Think back to grade 10. This is a trig equation, but what kind of trig equation is this? It's got a top and a bottom. It's a fractional trig equation, right? You had lots of trig equations in the grade 10 pre-cal, I think. You never actually solved fractional equations. Well, you did, but the very first thing is you identified an LCD and you got rid of your fractions, right? Agreed? So what's your LCD here? Okay. So eliminate fractions by using LCDs, and then, just like we've done before, LCD would be cos of x. Okay, every term gets multiplied by cos x. So what do we get here? We have 3 cos squared x plus cos x equals 2, right? Okay, what do your eyes see? Is this still an equation? What kind of equation is it? Okay. We have a quadratic equation. That will frequently happen in this section when you're using identities. We have a quadratic equation, and we always solve quadratic equations pretty much, unless they're super simple and they only have 2 terms. This is a trinomial, right? Okay. Everything goes to one side. And just like all trinomials, and what we saw one of these yesterday, the very end of yesterday, always try and factor. Remember yesterday using the quadratic formula was horrible. For me anyway. I don't know, probably painful for you guys to watch me. And I kept botching everything yesterday. So let's factor. I think this one factors. Does it, Joanna? It looks like it factors. I think I've seen this set of numbers before. 3 cos x and a cos x. Yeah, I think a minus 2 and a plus 1. So then cos squared plus 3 minus 2 and then a negative 2. Okay, so we've got our two factors. We're using our zero multiplication rule. Two things multiplied together equals 0. That means either they both equal 0 or one of them has to. So 3 cos x minus 2 is 0, or cos of x plus 1 is 0. This one's easy, right? Cos x equals negative 1. Whenever possible, we're going to use our knowledge of special angles. We're solving in radians, correct? I only have to do one rotation, so that's nice. Okay, where does cos equal negative 1? Okay, so there's one solution. And this one, what am I going to get? I'm going to get cos of x equals 2/3. That is not a special angle, right? So I'm going to just move down here a bit. I got to solve for my reference angle first. I guess I try to do this. As soon as I isolate cos, I just identify, is it a positive or a negative value I'm dealing with? It's a positive value. That means my answers will be in 1 and 4. So pick up my calculator, make sure I'm in radians. And I get a reference angle of 0.8410 dot 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 dot. That means I'm going to just leave that in my calculator. I'm going to store it, and I've showed you guys that before. In quadrant 1, it's kind of nice because my reference angle is my answer. So I'll go to 3 decimals, so 841. In quadrant 4, it's 2 pi takeaway. Right? So it's 5.442. Clock in your head if the numbers you're getting make sense, if the radian measures make sense. And what I'm saying to you is, when I say clock that, you know what? Unfortunately, we can't rely on our special angle thinking anymore, which I think you guys are pretty good at. So I'm thinking, when I can't use special angles, these are the numbers I'm thinking about, right? So do both of those answers seem reasonable for my decimal radian measures? My first one is 0.841. That fits, right? That would fit here. And my second one is 5.442. That fits, right? So just make sure that they're in the ballpark, right? Okay, so those are my answers. This is an example. Remember yesterday I said when you have a quadratic, one of your factors can lead to special angles, and one of your factors might lead to the calculator, unfortunately. How many people like solving from the memory, like the special angles, better than the calculator? Don't you? No one? Don't you think it's easier? Yeah. It's hard. To me, it's harder to pick up the calculator and record to 3 decimals and all that stuff.
Something about the calculator is a little bit more pressing than my memory.
Oh, okay. There's that. Okay, so that was question 1, or part A. Part B is the same. They're saying for all of these solve from 0 to 2 theta. So I'll just rewrite my B just because I kind of wrote over it. So my B is, I just tend to write big. Okay, this is a trig equation. It's already a quadratic equation, right? But it's got mixed up sines and coses again. So, is there any way I could write this equation just in terms of all sines or all coses? Joanna, what could I do? Sine? What would you do, Joanna? Yeah. See this guy here? Cos squared. What's cos squared also equal to? Yeah. So if I replace the cos squared with 1 minus sine squared, there, I have my equation in terms of sines only. It looks like it's gonna be a quadratic still, right? Because we've just replaced a cosquared with a sine squared. Okay, so let's multiply that through, see what we get. So quadratic, right? I never like starting any math equation with a negative if I don't have to. So I'm gonna just pretend I'm flipping them to the other side, or I'll multiply every side by -1 to get rid of the negative. So I'll have a positive 2 sine squared x, a positive 3 sine x, and a -2. And if I multiply the 0 by -1, it just stays 0. Okay, that just makes it look nicer. I don't want to factor with negatives. Can you see? Yeah. Okay, I think this one factors too, right? I've seen the pattern before. And I need a 3 in the middle, so that means I need a 4 outside and a 1 inside. Okay. So 2 sine squared plus 4 minus 1 and the -2. Okay, I'm going to let you go ahead and solve for x, because I haven't solved for x yet. And remember, you're solving from 0 to 2 pi. Okay, what'd you get? What was the second one, Eduardo? Because you're quadrant 2, right? I see signs positive, so it's positive 1 and 2. And then what happens over here? Do you remember, how many people remembered that one right away? Excellent. Yeah, just do a slash. Remember to show your slashes though. You have to show me that. Or either write out no solution. Okay, so that's how you deal with an equation. You'll know when you need an identity because you have mixed up trig functions that you can't combine. I'm going to jump a bit so I can give you lots of work time still. I'm going to leave this one. We can come back when we start reviewing. I want to talk about this one. This is a weird one. I want you to think about it for a bit. What would you do with this one? Could square it? No, that might work. Give that a try, Adam. I think it might work. Joanna, you had an idea before you were talking to me about something like this, didn't you? I thought you did, when you had sines and coses mixed up. Okay, so this was Joanna's idea. I thought this was a good one. Separate them. Now, the reason this works here, and it didn't work here, okay, you see that, like, it kind of looks different. Here I had a cos squared and a sine. Here I just have a sine and a cos. So I can't use the Pythagoreans, right? Like, I can't replace a sine with the cos has to be squared. But Joanna's idea was separate them, and what do you want to divide by? Cos. So as long as I do the same thing to both sides, mathematically it's sound, right? So then what do you get here? You get a tan x equals root 3. Oh, sorry, negative root 3, thank you. Negative root 3. So where does tan equal negative root 3? Tan has a value of root 3, I think at the pi on 3's, right? So it would be 2 pi on 3 or 5 pi on 3. So try, I mean, if you have sines and coses and no squares, if you have squares, of course, use Pythagoras, but this way we're kind of stuck. So this is not an identity you see every day, but just something to keep in the back of your mind. What if I gave you this identity? That just as an interesting one. I'm telling you, you don't even have to use this technique. What if I gave you this, or this, not identity, this equation? Just look at it for a sec. You're solving for x. You're thinking, right? If I just said sine x equals cos x. I mean, you could do the same thing, but you could divide by sines or divide by coses. But you could do it just, if you kind of thinking of the unit circle, what does the statement say? Sine x equals cos x.
Oh, 45 degrees.
So where does that happen? Yeah, at 45 degrees and one other place where they have the exact same values, the exact same signs. Not 135. Here and here, right? 225. Right? If I said sine x equals minus cos x, it would be here and here, right? You could do the same process for sure, right? And you would get this. You would get the same answers. So let's see. Just say, oh, okay, let me divide by cos x. And here's where your 1 comes into it, Adam. So then that means tan x equals 1. Okay, well, where does that happen? At 45 and 225. Right? Okay. One more with you, and then I'm going to leave it, and we'll finish the rest. What if we had something like f? Sine squared equals cos minus cos 2x. That's a tough one. What would you do here? Just think about it for a sec. If I divided by sine, I'd have a sine left, and I'd have a cotan, and I don't know what this one would be, so I think I'd be introducing more trig ratios, but I think that's an idea. You're thinking. We have sines and coses mixed up again, right?
Why don't we divide by cos?
I think if we divide by cos, and where do we, the problem is I have a squared over than a single, right? So Neville said, change the sign squared? Okay, why is that maybe a strategy to explore? If I change him to 1 minus cos squared, right? Then I have everything in coses, right? Except I have this double angle. I can't solve with double angles. Notice this has a double angle and this guy has a double angle. It's hard to solve with multiple angles. We'll learn a technique on Monday, but so far we don't know. So now I've got cos squared and I've got a cos. Can I rewrite my cos double angle in terms of coses? Okay, so let's just write him. This is where it comes in handy to have 3 versions, right? So I have 3 versions. I'm gonna pick the one just with coses. 2 cos squared minus 1. 2 cos squared x minus 1. Remember to use brackets, because you're replacing one term with 2, and you have to subtract both terms, so use the brackets. Okay, let's clean this up a bit. I've got 1 minus cos squared equals cos of x minus 2 cos squared plus 1. So we have another quadratic, right? I think I'll move everything to the left. So a negative cos plus 2 gives me positive cos squared. And then a minus cos x. And my 1's just cancel out, right? So this is a quadratic. It's not trinomial, but it's got 2 pieces. You can factor this one, right? So how do we factor this one, Rahel? I heard you say yes, we can. Yeah, common factor of cos, right? So I'll factor the cos out. Okay, so I have my 2 factors. I'm going to use my zero property rule. Cos of x, zero product rule. Cos of x equals 0. Cos of x equals 1. Okay, we're solving from 0 to 2 pi. So that means x is pi on 2 and 3 pi on 2. Or x is, now, I've got to look at the domain closely. Okay, so they're including both of them, right? 0 and 2pi. Sometimes they don't include the 2 pi, so you have to be careful, but this time they want them both. So 0 and 2 pi. Yeah, so those are all the solutions. Okay, I'll leave the rest for, we'll do some more examples. Now, what you can do is, I'll add another question to the homework. So, I said 1 through 5. You can add number 6 on now. And you can actually, if you want, you can do number 7, but just remember they're saying graphing, so their answers are going to always be in decimals. If you solve with exact values, just put your exact values in the calculator and make sure they match the answers. If you're, and I'll stop there. We haven't done number 8 yet, so we'll save that for Monday. So do 1 through 7. Now, you could also, we're just about getting ready to think about the test. You can start the chapter test. You should be able to do everything on the chapter test, except for, I think, excuse me, the only one you can't do is number 15. But everything else looks good. Of course, like when they say use graphing, you're just solving it algebraically. Okay, that person with the car alarm, I wish they would figure out how to use it, right? All right, so you can do everything. If you have time, start the chapter test. You've got a long weekend.